All right, guys, let's go ahead and take a look at some more examples with our hyperbolas. So I'm going to go ahead and jump down to example 3 in the notes. I'll leave example 2 for you guys to try on your own, and you can compare your answers with what I posted online. So on this one, it asks us to find the equation of a hyperbola with its center at 3, -1. I'm going to go ahead and just plot this as I read. So its center at 3, -1. We have a focus at 8, -1, and we have a vertex at 5, -1. Okay, this was our center, our vertex, and our focus. Okay. All right, so we're trying to find the equation of this hyperbola. Okay, well, the first thing that I can see here is based on the placement of all of these, we definitely have a hyperbola that's going to be opening to the left and to the right. So I know we're going to have a horizontal transverse axis. All right, which means we're looking at the equation x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Okay. All right, so we know that the center is at 3, -1, which is, of course, the h and k in our equation. The vertex is always found by using the a value. So the distance from the center to the vertex gives us a. So in this case, from the center to the vertex, we have 2 units. So a is equal to 2. The focus is going to help us find the c value because we know that the distance from the center to the focus is equal to c. That's going to be 1, 2, 3, 4, 5 units. So c is 5. And then the last thing we need to find is b. So for that, we can just use our formula. B squared is equal to c squared minus a squared. So we'd have b squared is equal to 25 minus 4, or b squared is equal to 21. All right, and then just plugging it all into our formula. Let me just move this up a little bit so I have more room. All right, so we are going to have x minus 3 quantity squared divided by 4 minus y plus 1 quantity squared divided by 21 is equal to 1. Just plugging in the 3, -1 for our h and k, plugging 2 in for our a, so 2 squared is 4, and then plugging in the 21 for our b squared. So that is going to be our final answer. Okay. All right, let's go ahead and look at example 4. So first thing you should notice on this one is that it's definitely not in our standard format. So the very first thing we're going to want to do on this one is to complete the square. So completing the square, remember we want to start by sort of just rearranging, so group our terms together. So I'm going to rewrite this as 9x squared plus 72x minus 4y squared plus 8y is equal to -104. So I grouped my x's, I grouped my y's, I got the constant out of the way, moved it to the other side. Okay, now before we can complete the square, we need to pull the GCF out of both our x terms and our y terms. So with our x's, I'm going to go ahead and pull out a 9. We have an x squared plus 8x and then plus whatever we need to add to complete the square. With our y's, I'm going to pull out a -4. So we'll have a y squared minus 2y plus whatever we need to add to complete the square. All right, and then that's equal to -104, and we'll have to, of course, add something in order to balance this out. Okay. All right, so let's try and figure out what we need to add here. Okay, so completing our square with the x's, we have an 8 as our b term. Divide that by 2, we get a 4. 4 squared is a 16. Okay, now remember, it's not just as simple as adding a 16 to the other side, though, because we have this 9 out front. So we have to remember to multiply the 16 by the 9, which will give us a 144 that we're adding to the right-hand side. Okay. All right, with our y's, we have a negative 2y in the middle. So negative 2 divided by 2 is a negative 1. Negative 1 squared is 1. So 1 times the negative 4 out front, we're going to add a negative 4 to the other side of our equation. Okay. All right, so simplifying this, we are going to have 9 times x plus 4 quantity squared minus 4 times y minus 1 quantity squared is equal to 36. All right, now like we talked about before, with hyperbolas, you always need the equation set equal to 1. So we're going to have to divide the whole thing through by 36. All right, so 9 divided by 36 is going to give us 1/4. That's going to be x plus 4 quantity squared divided by 4. And then 4 divided by 36 is going to give us 1/9. So that's going to be y minus 1 quantity squared divided by 9 is equal to 1. Okay. All right, so now that we have it in this format, it's going to be a lot more easy to figure out all the different pieces. Okay. All right, so let me first identify my a and b. So remember, a is always first with hyperbolas, and b is always second with hyperbolas. So the square root of 4 gives us 2 for our a, the square root of 9 gives us 3 for our b. Because the x squared term is first, our transverse axis is horizontal. Okay. From the h and k, we'll find our center at -4, +1. So let me go ahead and just start plotting some of this. So center is at -4, 1. Our transverse axis is the horizontal line that passes through the center. And the conjugate axis is the vertical line that passes through the center. Okay. Next, from our a value, we can find the vertices. All right, so just from the center, we're going to go 2 units right and 2 units left to get our vertices. Okay, those are going to be at -6, 1 and -2, 1. From our a and our b value, we can find the asymptotes. Okay. All right, so for these, remember the equations of our asymptotes are going to be y minus k is equal to plus or minus b over a times x minus h. So for us, we are going to have y minus 1 is equal to plus or minus 3 over 2 times the quantity x plus 4. Okay, all right, now I'm going to leave the equation of my asymptotes in that format. Okay, you might be tempted to solve for y, rewrite it in slope-intercept form, but honestly, it's going to be better if you just leave it in this format right here, because then we can just count from the center. So basically, this is saying that if we go from the center, we just have a slope of 3 over 2. So we're just going to go up 3 over 2. So from our center right here, just going to go up 3 over 2, plot a point, and then we can just connect this as a straight line. draw on your line there. Something like that. And we're good. Okay, and then just same for the negative slope. So again, from the center, I'm just going to go down 3 over 2 and plot my point. Okay, that gives us our asymptotes. Okay, all right, so we're almost done. The only thing left are the foci, and for that we're going to need our c value. So we can again use, b squared is equal to c squared minus a squared. Plug in 9 is equal to c squared minus 4, which would give us c is equal to the square root of 13. Plugging that into our calculator, that's approximately 3.6. So that's going to give us our foci. So from the center at negative 4, 1, we're going to count 3.6 units right, 3.6 units left, and those are going to be our foci. Okay, so if we go 1, 2, 3.6 units to the right, that's going to put us right around there at negative 0.41. All right, and then if we go from the center 1, 2, 3.6 units to the left, that's going to put us at negative 7.61. Okay. All right, so then the last thing we need to do is just draw our curve in. So it's going to pass through the vertices and approach the asymptotes on the edges. So just kind of do your best to sketch it in. Doesn't have to be perfect, as you get that general shape. It's going to look something kind of like that. Okay. All right, guys, so that is pretty much it for our hyperbolas.